This is the 4-bar mechanism, and in this 4-bar mechanism we know length of the each link, and we know angular velocity of the only link AB. So that is the link 2. This is considered 2, 3, this is a 4. Then we know only angular velocity of the link 2. Then how to find out different linear and as well as angular velocity of the other links. So using the basic concept that we just learned, we can find out velocities of any given mechanism. So before proceeding that, we need to remember few things. So whenever we get a mechanism like this, first of all, first step is identify fixed points, draw known velocities, and third step is draw velocity vectors which are unknown, but we know the direction of these velocity vectors. So whenever we are drawing such velocity vectors, it's better always to continue from at the end of known velocity vectors. So what does it mean? We will see in this example. So here, according to this one, so first of all I will mark the constant or fixed points. Here in this case, what are the fixed point? A comma D. So I mark this one, and here in this case, what is the known velocity? So here we know only Vb. So we know only Vb because omega 2 is known. So omega 2 into AB, and we presume that we know all link lengths. So only Vb is known and remaining velocities are not known. So you draw Vb. How to draw Vb? So we know Vb is like this. So Vb, direction of Vb is like this. Vb is perpendicular to the link AB, and this is moving in this direction, so that this is also move in the clockwise direction. So what is the velocity of this C? This is in this direction, but we don't know magnitude, but we know that the velocity should be in this direction. So first I will draw Vb. This is the Vb. Vb, I know its magnitude also. So this is a Vb. Vb means velocity of the B with respect to point A. But anyway, point A and D are constant, so that's why I am not mentioning here. And I know direction of the VC. So I am simply drawing direction of the VC. So this is the VC, but I don't know its magnitude. So I don't know where to stop. So I just draw a very big line. And from this end, from what is the velocity of the VC? Velocity of the point C with respect to point B. So it's a direction. Velocity of the C with respect to B should always perpendicular to the point joining. This is a VCB. But this is a perpendicular to the line joining these 2 points B and C. So again, from V and C, this is moving in the clockwise direction. This is also moving in the clockwise direction. But here in this link is rotating like this. So this is rotating like this. That means at this position, if you draw a perpendicular to the BC from B, so that should be something like this. This is a perpendicular. So the point where it's joining is a C, and this is B, and this is a CB, and this is a VC. So from this velocity triangle, we can measure this value. So what is the VC? We know VC from this diagram, and that is nothing but omega 4 into CD, but we know CD. From this equation we can calculate omega 4. So omega 4 equal to VC by CD. And if you want to calculate the angular velocity of this link 3, then how to calculate? So again what is the relative velocity? So that is a VCB equal to omega 3, the angular velocity of this link, into distance between these 2 points C and B. So that is a BC. So from this equation we can calculate omega 3 of the link VCB by BC. And further, if you want to find out the velocity of the E, the velocity of this point E also on the link 3. So how to find out velocity of the E? So we know point B, this is a point B, and we need to draw a we need to draw a velocity vector in this direction, because this is perpendicular to line joining B and E. So from here I will draw a line parallel to the velocity vector VEB, like this. And from from C to E, again this is also actually this is moving in this direction. So at this instant its velocity is going in this direction, because here this is moving in the clockwise direction, this link, and this is also moving in the clockwise direction. So since this link 2 and link 4, if you observe geometrically, so this is going in, this length is less than this one. Since this length is less than this one, so it's a move like this, and it go like this link go like this. So for example, if it at this position, if B is at this position B, then C would be at this position. That means this C and E, this will rotate like this. This point E will rotate in this direction. So this point B is going in the clockwise direction, C also going in the clockwise direction, but point E is going in the anti-clockwise direction. So that's why this should be in the downward direction, or otherwise I will write in a green color. This should be in the downward direction from the E. What is this point? What is this one? This is nothing but V, velocity of the E with respect to point C. So here if you draw a line parallel to the velocity vector EC, then it come like this. So it intersect here. So this is the point E. So this is a point E, and if I join this point, and if I join this point with A, this is the velocity of the E, that means absolute velocity. So how to write absolute velocity? This absolute velocity of the point E, VE equal to, either you come from the velocity triangle ABE, that means velocity, what is this one? This is the E velocity B, this is the velocity of the E with respect to C. So this can be written as velocity of the EB plus velocity of the B, or this can be written as, if you come from a triangle DCE, so that means that is the velocity of the E with respect to point C plus velocity of the C with respect to point D. So in either way we can calculate this point E, velocity of this point E. And here we have one more point, that is a point F. For example, if I consider this point at a distance F, and we have already seen that velocity is proportional to the length of the link, or from distance from which it is moving. So it's proportional to the distance. So we have already known the velocity of the CB or BC proportional to BC. So what is the velocity of the FB? Velocity of the F proportional to the FB. So that means velocity of the FB by velocity of the CB equal to FB by BC, because these both are in the same link. That means here proportional. Why we have written proportional? If you remove the proportional, then I need to put here angular velocity of the link 3. So instead of putting angular velocity of the link 3, I have written proportional. So if I do like this, then we can calculate linear velocity of the point F with respect to B. So under this linear velocity of the point F with respect to B should lie on the line joining F and B and C, because this F is on the line joining B and C. In the same way, velocity of the F or FB should be on the line joining B and C in the velocity triangle. In the velocity triangle, for example, from here to here, this is the velocity CB, and this CB velocity CB is proportional to BC, and in the same way this FB is proportional to the FB, yeah, distance FB. So I will mark from this equation, I will calculate some value and I will mark that somewhere here. So let's say this is the F. So this distance, so let me redraw this diagram again. So this I have rewritten the same velocity diagram. Here I mentioned a point F. So distance, I mean if you measure from here to here, that is a velocity Fp, and if I want to find out the velocity, absolute velocity of the point F, then again I simply draw a line from here joining the point F. This is absolute velocity. So what is the absolute velocity of the point F? Again, this is a triangle ABF. That means velocity of the F with respect to point B plus velocity of the B, or this can be written as velocity of the point F with respect to point C plus velocity of the C. And this is how we can calculate all the linear and as well as angular velocity. And here, before moving on to slider crank mechanism, here I would like to mention few important points here. In the configuration diagram, all symbols are in the capital letters, but here in the velocity diagram, the corresponding symbols we have written in the small letters. And whenever I am writing velocities, even the suffixes also in the small letters. And whenever I say velocity of the point, any point, for example A with respect to B, then that can be written as A with respect to B. Here whenever I write a second letter, that is a difference one, and the first letter is we need to find out with respect to the second letter, that is a B. Here in this case velocity of the A with respect to B. And here in the velocity diagram, always we need to identify the fixed points, and you mark all the fixed point, or you affix all the fixed point to a one point. This is a slider crank mechanism, and here only angular velocity of the input link is given, that is a crank OA has given, and we need to find out angular velocities and as well as linear velocities of the other link. This is a coupler link, or we can say it as a link 3, and velocity linear or linear velocity. Here the slider can have only sliding velocity, its angular velocity is 0. So what is the sliding velocity of the slider? So we need to find out these different parameters. So again, first of all, first step is we need to identify fixed point, and second step is draw known velocities, and after that draw unknown velocities which are starting from the end of the known velocity vectors. So we need to follow these 3 steps. Here what is the known value here? So known value is VA, because here omega 2 is given, this is omega 2, and we know length of the all links, so this is OA. So we know value of VA, and what's its direction? its a direction is like this, because in this instance this is rotating in the clockwise direction, so that velocity of VA should perpendicular to the link joining O and A. So this is like this. And what is the direction of the point B? If you consider point B on the slider, so what is the velocity or direction of the velocity of a point B? So this is in this direction, because this is moving at this instant, this is moving in this direction. And what is the velocity of the B with respect to A? That should be perpendicular to the line joining A and B. So this is a B with respect to A. So that means velocity of the B drawn from the point A. So let's draw the velocity diagram here, velocity polygon or diagram. First of all, we identify fixed points. Here only one fixed point, that is O. And after identify fixed point, you draw velocity vector, noun velocity vector. Here this is the only noun velocity vector. So you draw a line of the same magnitude parallel to the velocity VA. So this is the VA, and after that we need to draw unknown velocity vector from the which is starting or which can be drawn from the end of the known velocity vector. So here this unknown VB and as well as VBA are unknown, but here VBA can be drawn from the end of the known velocity vector VA. Why? Because this velocity magnitude, this length of the VA also we know, because we know magnitude. So from you draw VBA vector from the end of the VA in a such a way that it should be parallel to the VBA. So we don't know its a magnitude, you just draw like this, and this is a VBA. And after that, this velocity of the B, again this velocity, this slider, this is also point 1, or we can consider this also point O. So this is a link 1 and this is a point O, we can consider point O also, though this slider is moving in this direction, and this slider is sliding with respect to ground or link 1. That means it's moving with respect to point O. So can you draw the velocity of the slider that which is always horizontal and in this direction, and that is with respect to O, because it's directly moving on the reference plane ground or reference link 1. So that can be written or drawn directly from the fixed point O. So these two are meeting at this position, so this can be written as a B, because this is a VBA and this is a VB vector, so both are touching here. So this is the point, and this is the VBA at this position, and from this triangle we can calculate VB. VB equal to length of the OB, and VBA equal to, from this triangle, this is the length, this by measuring this and this we can calculate what that means, that is the omega 3 into AB. So again, if you need to find out omega 3, that is a VBA by AB. And if I further extend this one like this, so this link is hinged at this point, link 2 and 3 are hinged at the point A, but link 3 is further extended in a such a way that we have another point like C here, at C here. So how to find out velocity of the C in this case? So this point C is on the link joining BA. So we already seen velocity of the B with respect to A by velocity of the C with respect to A equal to distances AB by AC. So from this one we can calculate CA equal to we can calculate CA from this equation, and in this diagram this is the VBA, and this CA is should be drawn from the point A. So you can, from the value you can you can mention CA, but CA on which direction? Is this CA on the, is this CA here, or should come outside? Because it should come outside, because the C is not on the in between point A and B, but instead it is on the extended line. So in the same way, if I draw a line like this, and the equivalent amount of CA should be mentioned here. So this is the point C, and this is the velocity CA, and if I want to find out absolute velocity of the point C with respect to point A, this is the VC. So how to find out VC? Again, VC equal to, I take, this is the point A, I take triangle OAC. So this is a VCA plus VA, because this is a VA. And instead, if I take triangle OBC, so how to close this triangle? From, you travel like this and like this, like this. So if I travel from O to B, that is the velocity of the B, plus from B to A, it's a in the negative direction, we are going in the opposite direction. So that is the velocity of the A with respect to B, plus velocity of the C with respect to A. But here we have written velocity of the A with respect to B, but we know the velocity of B with respect to A. So if you want to write velocity of the B with respect to A, then again it changes sign, that we already know. So what I am saying is, or if I write in the, if I go from this direction, so how to close this triangle? So velocity of the C with respect to A, that we have written, and the velocity of the A with respect to B, that we have written, and the velocity of B with respect to O, that also we have written.